In the previous couple of videos, we looked at the sharing method called divider selector, and in that method we had one divider who was chosen randomly and everyone else became a selector. This is kind of, in a way, the reverse method. This is called single selector, which means that we only choose one person as a selector and the rest of the people act as kind of like dividers. So let's just see how it plays out in this scenario. So we have three people and we have a new upgraded pizza with new toppings. It's split into thirds. 1/3 has anchovies, 1/3 has green peppers, and 1/3 has sausage. And the pizza's worth is $10. So now we have three people and they all have different preferences that they are saying in their speech bubbles. So now let's pretend we randomly choose someone to be the selector, and let's say the person ends up being C. So he's going to be the selector, and then A and B will be our two dividers. Now, before we go on, let's draw the mini diagrams for everybody just so we can work out the math a lot easier. So let's look at A. He likes green pepper just as much as he likes sausage, but anchovies are worth to him twice as much as either of those. So let's draw his mini diagram right now. So we'll split it into thirds like this. So he likes green pepper as much as sausage, but anchovies are twice as much as either. So if we call green pepper X and sausage X, then anchovies for him are 2X. And all of this must add up to 10. So 2x plus x is 4x equals 10. So that means x is 2.5, which means for him, this piece is worth 2.5, this per 2.5, and this piece is actually worth 5. Okay, so now let's look at person B. For him, he doesn't like anchovies at all, so we can already say that this piece is worth 0. And he likes sausage just as much as green pepper. So he's going to split the rest of the value equally among these two pieces. Now, the last person is the most complicated. So he likes, for him, anchovies are worth twice as much as green peppers, and green peppers are worth twice as much as sausage. So if we kind of infer, we can see that anchovies are worth 4 times as much as sausage. So what does that mean? If sausage is worth x, then green peppers are worth 2x, then anchovies are worth 4x, and all of this must add up to 10. And this comes out to a little bit of a not nice number, but I've worked it out. So if we look at this person, so it turns out that x comes out to about 1.43, and that's going to be the least valuable piece, the sausage. The green peppers are going to be twice that at 2.86, and the anchovies are most valuable at 5.71. And if you look at these numbers, add them up, they'll add up to 10. And these are estimates. Of course, I left off the trailing decimal points and stuff like that, or rather the extra digits. Okay, so now we have this. So now let's actually play the game and see what happens, how we play the game. So we have designated A and B as the dividers. And now actually they're not both going to be true dividers, because now between themselves they must do another random draw and they must play two-player divider selector. So now let's say they play two-player divider selector, and we see that B has to be the true divider, and now A will be the selector for two-player divider selector. So let's say that, here's a view of the pizza again. B is going to divide it how? So we see B's mini diagram is here, 5, 5, 0. So here's a possible way he can divide it. Let's say he divides it according to this black line, just like this. So 2/3 of the pizza are in this slice, and 1/3 is in this slice. So remember, for him, this is worth 5, this is worth 5, this is worth 0. So both these pieces, this 2/3 of the pizza is worth 5, and this last 1/3 is worth 5. So for him, he has done his job because he has divided into two pieces that are equal worth to him. Now, A is going to be our temporary selector. He's not the true selector of the game. He's just for this round, for this smaller case. So he's going to select which one he likes better. Let's look at his mini diagram. If we call this piece right here, piece 1, how much is that worth to him? It's worth $2.50. And the other one is worth $7.50. So he's obviously going to want to choose piece 2. It's worth $7.50 to him. So now, B is stuck with piece 1, and he's okay. He has $5, which is a fair share. So now you're asking, how does C factor into this? And now this is where this method is different. So, so far we have two pieces. We have, from this picture, we have a piece that's 2/3 of the pizza, and we have a piece that's 1/3 of the pizza. And now, each of A and B, their job is going to be to divide each of their own respective slices into 3 equal slices. So let's see how to do that. So we decided that piece 1 belongs to B, and piece 2 belongs to A. Now let's say A is going to do his job. He has to split this up into 3 equivalent pieces. So remember, this is worth 2.5 to him, and this is worth $5 to him. So if he's going to split into 3 equal portions, then they each have to be worth 2.5. So here's his first piece, which is the whole sausage slice, and now he's going to divide the anchovy slice into 2, and that's going to be his second piece and third piece. So let's label them 1, 2, 3, and indeed they're each worth $2.5. So he's done his job. Now B, his job is even easier. Since this piece is just worth $5 to him, all he has to do is divide into thirds. And now each of these thirds is worth 5/3 dollars to him. Okay? Now C comes in. He is the true selector of the game. His job is to pick his favorite slice from each of theirs. So each of them has 3 slices. C's job is he's going to go in and pick one from each person, and that's going to be his share. So let's see how he's going to do that. That's going to depend on what he likes. So I've put C here. He values this portion right here at 2.86. So as he splits it up, it's going to be, each portion is going to be about 95 cents. It's actually 95.333 cents, but we'll just keep it simple. So each portion is about 95 cents to him. Now, he's going to look at this portion right here, and he's going to say, which is most valuable to me. So he says, this is 5.71. So each of these is half of 5.71. And that's going to be for him 2.86. So this is 2.86 for him, this is 2.86 for him, and this last piece down here we established was 1.43. So this does seem complicated, and I'll explain the merits of this method because you might be thinking this is just overly complicated at this point. So we'll explain the merits of this method, maybe this video, maybe in the next video. So anyway, let's finish this off. So now all the gray you see is how much C values this piece is at. So since all these are valued the same, he doesn't matter. He's going to pick any one. And he's obviously not going to pick the $1.43 one. He's going to pick one of the 2.86, but they're both the same to him. So he's going to pick those. And now if we add up the value that he's getting, so his fair share is going to be this piece 2 and this piece 1, let's say. Now if we add up the value that he's getting a total of $3.81 worth of pizza, and that's C. Now, what do A and B get? A and B get the remaining portions after C has taken his pick. So A is getting piece 1 and piece 3 remaining, so that's going to be worth how much to him? It's going to be 2.5 and 2.5, so $5. $5 goes to B, and A, $5 is going to A, and how much is going to B? So B is just getting 5/3 and 5/3, which is 10/3. So he's getting 10/3 or 3.33, or exactly 1/3 of the pizza. So that's how this works. So just to do a quick recap, you first have the whole pizza, you randomly designate one person as the selector, and the other 2 people will be they'll play a divider selector game. So you'll have those 2 people each play a divider selector game, and then once they each have their pieces, then they have to divide it into thirds, and then the last person, who's the selector, designated randomly, he'll come in and pick one of the thirds from each of the people and join them together, and that will be his share. And the other 2 people will just retain what they have after the last person has taken a third from each of their pieces. So that's how you play. And in the next video, we'll go over just n players, just arbitrary amount of players, and why this method works, why it ensures that everybody gets a fair share. So as you can see here, everybody got a fair share, because a fair share in this game would be 10/3, and this is 10/3, this is over 10/3, this is over 10/3. So until next time.